Okay, let's see, is the volume working? Let me just quickly check. Say something, come on. Okay, it works. Also, I forgot to turn on the music. Let's quickly open this, and shuffle play. Amazing song for the start. So, last time we finished lights. There's still some problems. For example, as you can see, a single light can light up the entire scene, which is not a very good thing. At least in my opinion, it's not very good. I don't think it's going to be fixing it, so I'm not really going to be looking into that right now. But after I finish this, I'm probably going to look into a better way of making not camera lights. So, yeah. So now that that's out of the way, also I'm going to change the model because for testing purposes I set another model. Let's see where am I making the model. Okay, load model, cube, object. Is this the one? Let's check. Yep, this is the one. As you can see, like, it lights up in front of it, but it like lights up everything in that direction. I don't really know how to explain it. But for example, this shouldn't be lit. This should also be dark. Yeah, see? Okay, so this is a really good thing. Let me quickly take a screenshot. So if we open it Paint, I'm not going to be fixing it right now because I have no idea how to. But if you open it here, you can see, let me select lines. Like the object is here, and this technically should not have light because it's way too far away from what it should actually be lighting. But no matter the distance, it still draws the ray. And because the ray has collision with this, it just then calculates the brightness of it. It doesn't matter the distance. And someone suggested doing something like ambient lighting, but I have no idea what that is, and I don't think I'm gonna be going to that. Like for example, yeah, let's take another face, like this one for example, like the face here. Wait, is that one face? I don't know, it's pretty difficult to tell that far away. Oh yeah, this face. See, it's still very, 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 very lit because the math formula still hits it, technically. So, yeah. Okay, let's close this. Okay, but today we're not going to be focusing on that. We're going to be focusing on okay, today we're going to be focusing on normal mapping. I think I already explained what that is before. So, yeah. With just lighting, our scene is already looking pretty cool. Wait, let me check. I'm gonna make it just a little bit quieter. Okay, let's go back. With just lighting, our scene is already looking pretty good. Still, our models are still overly smooth. This is understandable because we're using a very simple model. If we were using a texture that was supposed to be smooth, this wouldn't be a problem. But our brick texture is supposed to be rougher. We could solve this by adding more geometry, but that would slow our scene down, and it would be hard to know where to add new polygons. This is where normal mapping comes in. I think we already have normal maps. Yeah, cube normal. Okay. Remember when we experienced with storing instance data in a texture in the instancing tutorial? Saving instance data. Right. Remember when we experimented with storing instance data in a texture in the No, what? We were doing that? Our instance input was oh, does it mean like I think it means this calculate no, that just creates the instances. What do you mean storing instance data in a texture? Normal map is doing just that with normal data. We'll use the normals in the normal map in our light calculation in addition to the vertex normal. The brick texture I found came with the normal map. Let's take a look at it. Okay. The R, G, and B components of the texture correspond to the X, Y, and Z components of the normals. All the Z values should be positive. That's why the normal map has a bluish tint. We'll need to modify our material struct in model RS to include a normal texture. Oh yeah, that explains. I actually didn't know that RGB responded to XYZ in the normal texture. That's interesting. Okay, let's see. So let's go to our model. Go up, and in our model material, yep, here, instead of only the diffuse texture, we're also going to have a normal texture. Type texture, yep. We'll have to update the texture bind group layout to include the normal map as well. Texture bind group layout. Oops, that was not here, that was here. Texture, bind group layout. Okay, you know, I'm gonna copy this out. Wait, where? Binding. One. Is there something specific we need to add? Nope. What was this? Fragment. Multi-sample. Okay, so this was for the texture. Now we're gonna be doing for the normal map. Okay. So bind group layout entry. The second binding, our visibility is going to be fragment. The binding type is going to be a texture. Let's see, let's close this. Sample type. So 2D texture, oh wait, no. The WGPU texture sample type, float, filterable, true. Okay, the view dimensions are going to be WebGPU texture dimensions D2, and multi-sampled is going to be false. Count none. And another one. Bind group layout entry. Binding 3 visibility. Again on the fragment shader. I don't get why we need two different binding group layout entries for a texture. Maybe it's like explained here. Let's see real quickly. Where do we create our the bind group? Our texture bind group layout has two entries, one for a sample texture at binding 0 and one for a sampler. Oh yeah, one is texture, another one is sample. Okay, yeah, so one is to access pixels, another one is the actual image. And resources are S. Let's go here. Let materials, diffuse texture. We also have a normal texture now. So it's gonna be a load. Texture file name is gonna be m.normal texture. Device is gonna be device, Q is gonna be Q, and don't forget unwrap. And also this should be unwrapped. And we also do this here, normal texture. Yep. Nope. I don't need block on here, right? Yep. You'll notice I'm using a material new function we didn't have previously. Here's the code for that. Wait, where are you using that? Oh, model material new. So, okay, let's go to our model and model material, and we implement here for material. Why do you need a function though? Okay. Public function new is gonna take in device string. Wait, it's a WebGPU device. Okay, for a second there was what? String. And just in this thread is a string. Diffuse texture is texture, and normal texture is also texture. Our layout is gonna be WebGPU bind group layout. We're gonna be returning a self. So let's see. It just creates a binding group with specific, turns to self. Oh yeah, makes sense. Oh wait, no, it doesn't make sense. We already made the binding group here. Oh yeah, but it's not full. Okay, I guess that makes sense. Let's for now then just comment it out. Go here and create the binding group. Oh, I can just comment it out and I can copy it here. And there are two more entries now. So bind group entry is going to be a resource, WebGPU binding resource, texture view of our normal texture dot view. See, and another WebGPU layout entry. Oh wait, no, bind group entry. Bind group entry is going to be the third binding, and the resource is going to be WebGPU binding resource sampler. Is going to be normal texture dot sampler. Yep. Okay, so there is label. We're actually going to be setting the label to the name. Let's see. So this is normal texture. I'm going to set this to color texture and our normal texture. Okay, so let's see. So after all that, we need to return a new self of name is going to be name. Can I just use name here? Okay, no, I can't. I'm gonna have to do name dot toString. Then it's also gonna be diffuse texture, which is just gonna be diffuse texture. No need to change anything here. Our normal texture and our bind. Mismatch types. Why is there diffuse texture and option value? Why could this be? Why could this be? Expected enum option string. Oh wait, it expected it. Oh, the problem is here. Maybe I should do string from. What? What are all of these? It returns a self. Cannot define inherit implement for foreign type. Oh, misspelled name. Okay. Silly me. Okay, so bind group. Let's go back to our resources because now we need to do model material new. And these are going to be the parameters. It takes the name, m.name, diffuse texture, and instead of this it takes... Oh wait, it also needs device first. So device here, name, that's it. Font string, and reference here. Let's see, expected 5 arguments. What is the one that I'm missing? It is the layout. The layout of what? WebG Pine Group layout. Wait, which layout is that? You mean just layout? Oh yeah, wait, what? Where is this? Oh yeah, we're past it in. Okay, I forgot about that. Let's see what's... One more. Okay, yeah. Let's see. So we push the new material. I think all of it should compile. It's not going to change anything, just to see. Yep, everything still compiles nicely. So let's see what's next on the agenda. Now we can use the texture in the fragment shader. So let's go to our shader WGSL. We already have this for our normal texture. Oh yeah, it makes sense why it would name. Okay, well, let me just copy this. Binding 2, binding 3, nor. Yeah, okay, I'm gonna rename this to S normal and T normal. It's not gonna be consistent, but I realize why these names are better than what I chose. Okay, let's see now. Our object color. Wait, we're gonna be doing twice this stuff because of our normal? Okay, let's see. So it's gonna be object normal. Okay, I'm back. Okay, so our object normal is gonna be our T normal, S normal, in dot text coordinates. Yep. Let's see, ambient strength. Ambient color, still all the same. Light direction. Okay, something is new here. Create the lighting vector, so let tangent normal. So we're gonna be using, why do we multiply this by 2? I guess the values are too small. So is it let light direction, normalize position, world position, view direction. Okay, let me move this up so everything stays consistent. View direction and half direction also go here. Okay, the view strength is a maximum of a dot. And we're going to be using tangent normal for this and this. 0, 0, light color, specular color, and then we add everything up. If we run, they won't look quite right. Okay, let's see. What's not that quite right? It definitely looks way different. The color seems to be inverse. Also, what is that bright part over there? That's okay. We're probably gonna fix it now. Parts of the scene are dark when they should be lit up, and vice versa. I mentioned briefly. Oh wait, I need. Okay, no, I'm not gonna change anything. I mentioned briefly in the lighting tutorial that we were doing our lighting calculations in world space. This meant that the entire screen was oriented with respect to world's coordinate system. When we pull the normal data from our normal texture, all the normals aren't in what's known as pointing roughly in the positive z direction. That means that our lighting calculation thinks all of the surfaces of our models are facing in roughly the same direction. This is referred to as tangent space. Okay. If you remember the lighting tutorial, we used the vertex normal to indicate the direction of the surface. It turns out we can use that to transform our normals from tangent space into world space. We use the vertex normal to indicate the direction of the surface. Yep, it turns out. Okay. In order to do that, we need to draw from the depths of linear algebra. We can create a matrix that represents a coordinate system using 3 vectors that are perpendicular or orthonormal to each other. Basically, we define x, y, and z axis of our coordinate system. Okay, let's see. Let's create it on top of here. Coordinate system. And then people come up with stuff like this. Like, it's just insane. This math is so. Yes. I don't really know how to explain it. It's not that it's like consisting of very difficult to understand terms. It's just that using those not very complicated terms, trying to make something this complicated is just how. The tangent and the bit agent. We have one of the 3 vectors we need, the normal. What about the others? These are the tangent and bit agent vectors. A tangent represents any vector parallel with a surface, aka doesn't intersect with it. The tangent is always perpendicular to the normal vector. The bit agent is a tangent vector that is perpendicular to the other tangent vector. Together, the tangent, bit agent, and normal represent the x, y, and z axis respectively. So I guess this is the normal. This could be the tangent or the bit agent. Basically, we can use the edges of our triangle and our normal to calculate the tangent and bit tangent. But first, we need to update our model vertex struct in model rs. Okay, let's close this, save this. Where is our model? Wait, no, not model, model vertex. Position, text colors, public tangent, also vector 3, and bit tangent is also a vector 3. So we need to upgrade our vertex buffer layout as well. So we create new stuff. At location 3, it's going to be float 32.3. And in location 4, it's going to be float 32 also times 3. And we also need to increase this to 5. 1, 2, 3, 4, 5, yep. What do you mean expected? Has an incompatible type for trait expected vertex attribute 3. Why did you expect that? Is it because of this? Oh, it's because of this. Yep. It's a trait I'm implementing. I'm going to have to change that there as well. So our vertex attribute, okay, we said that. Now we can calculate the new tangent and bit tangent vectors. Update the mesh generation in load model in resource rs to use the following code. Load model, so we'll calculate these later. Wow, amazing. What does it do it? Meshes, with mutable vertices. This is the line. Yep. It maps each vertex. Oh, okay, okay. It goes through each, okay. Okay. Wait, I did that before as well, what? Okay, fine. So these are 0 for now. Am I doing this in the correct spot? This is meshes equals models into iteration. We map through each model. We get the mutable vertices. We get the vertex buffer. We don't need the vertex buffer anymore. Oh no, they're just in the very end here. So before all of that, we need to add indices. Okay. Let mutable indices be equal to our mesh indices. Okay. Mute triangles included. Calculate tangents and bit tangents. We're going to use the triangles, so we need to loop through the indices in chunks of 3. So for each chunk in indices dot chunks 3, let v1 v0, okay, be vertices c0 as u size. It's a model vertex. C0 is a list of u. Okay, so so it's gonna get 3 model vertices. I just change the values here. This is 1, This is going to be 2. This is going to be 2. This is going to be 1. Let the position... Okay, just... Calculate the edges of a triangle. Okay, delta position 1 is going to be position 1 minus position 0. What does delta position calculate the edges of the triangle? How will that calculate the edges of the triangle? What position 1 if we subtract, and why is it only 2 edges? Oh well, I guess we don't really need the third one because, yeah. Actually, why do we not? And this is so poorly explained. This will give us the direction to calculate the tangent and bitangent. So, solving the following system of equations will give us the tangent and bitangent. Delta position 1 equals delta uv1 dot x multiplied by type plus delta u dot y multiplied by b. Luckily, the place I found this equation provided the solution. What is all of this? Okay. Let delta position be equal position 1 minus position 0. This is going to be position 2 and position 0. Let delta UVs UV1 minus UV0. This is 2 and this is also 2. Tangent and tangent. What is this R? Okay, this is just absolute BS at this point. It doesn't even matter if I write the code because I'm still not gonna understand it. Tangent, bitangent, R. What? How does this get our edge position? Let's go here and create something. So for example, this, and the other one like this. Let's say we have a triangle with 3 points. This is one of the points, this is another. This is this one. XYZ. If this is gonna be, let's connect the points. So this is gonna be, for example, oh, does it need to be perpendicular to each other here? I don't know. So for example, this point is on the x-axis 2, 1, 1. This is gonna be 3, 1, like 4. And this is gonna be 5, 2, 1, for example. So what we're doing, I think it has to be perpendicular here, so I can just make up numbers. Okay, let's go to 2D space. It probably applies to 2D space as well. It's easier here. So we have dot here, we have dot here, we have dot here. Although that makes like literally, okay. This. So this is gonna be 1, 2, 1. I don't know, 5. No, still 2, 5, and 6, 1. So by dividing, the problem is I don't even know, like, so position 0, V0, which vertex is that? Is it this one? Is it this one? Is it this one? Does it not matter? For example, let's say that position 0 maybe is the center. I mean, by the center I mean this. So we get position 1. So for example, this, we do 2, 5 minus 2, 1. That's gonna be 0, 4. What is that? I have no idea what this is. What does it do here? Oh my god. Okay, at least let me understand what tangents and bit tangents are again. I mentioned briefly, okay, I read all this. When we pull the normal data from our normal texture, all the normals are in what's known as pointing roughly. Wow, that's an amazing name, pointing roughly in the positive z direction. That means that our lighting calculation thinks all of the surfaces of our models are facing in roughly the same direction. This is a reference to as tangent space. If we remember the lighting tutorial, we use the vertex normal to indicate the direction of the surface. It turns out we can use that to transform our normals from tangent space. Yeah, okay, I get this. But then it starts doing crap like this. And like, what? Making a coordinate system? Okay, I'm just gonna roll with it. I don't know. I'm gonna try to probably understand it later more. So it's delta position 2 multiplied by delta UV1. Delta position 1 multiplied by delta UV2. What? This is supposed to be multiplied. We use the same. Okay, it can explain it with how much it wants. I'm still not gonna understand it. Just copy this here. Yes, of course. It makes so much sense that what we do next is average them. Yes. So smart. This is actually pissing me off even more than win it somehow. I thought it would be impossible. And why are you saying that this should not be mutable? It is being changed. How is it fine with a... Is it because it references a mutable variable? Probably. Okay. Our model mesh, okay, everything else is the same. World space to tangent space. What are we doing here? Was this all just to calculate the tangents? Can't we just... Okay. World space to tangent space. Since the normal map by default is in tangent space, we need to transform all the other variables using that calculation to tangent space as well. We'll need to construct the tangent matrix in the vertex shader. First, we need our vertex input to include the tangent and bit tangents we calculated earlier. Where's our shader? Vertex input, tangent, bit tangent. Construct the tangent matrix. Oh, also the vertex output has been changed. Tangent position. Oh, maybe it's not bit tangent, it's bitangent. Wow, I'm stupid about that part. Still doesn't help. Bi means two, not second, so like it still doesn't make sense, the naming. Wait, does bi mean two or second? Oh, it does mean. Yeah, two, twice, or double. It does not mean second. Oops. Where did it? Okay. Oh, I didn't create it yet. I skipped. Position equals model matrix multiplied by vec4 of 32 of our model position and 1.0. Tangent position, tangent matrix multiplied by work position xyz. Tangent view position, tangent matrix multiplied by camera view projection at xyz, and tangent right position is going to be tangent matrix multiplied by right dot position. I mean, I can understand how this works. It's not hard, but like it still doesn't help because I have no idea what tangent is. It's oh, it's that. It's just that I do not study math in English, so a lot of the English names I do not understand. Wait, yeah, okay, no, I do know what it is. I guess it just has two names. Not the fact that it has two names, it has one name, but it's also used for this, but I don't think this is helpful in this situation. Okay, what is bitangent? Oh, crosses two dots. Insane. So this is the tangent. The blue one. Oh wait, no, it has different colors. I guess we're gonna be multiplying the tangent matrix by the world matrix next. Oh wait, no, we already got world position. What? Okay, let's scroll down. Finally, we will update fragment shader to use these transform lighting values. Tangent normal, light direction. So basically going to be doing everything relative to the tangent, face, surface. Oops, what did I do? No idea. And dot tangent position. And our view direction. I guess it should be in dot tangent view position minus again tangent position. So basically just calculates everything relative to this tangent and bitangent surface, which is, oh, I guess we calculate both the tangent and the bitangent because the surface needs three, how do I say, not lines, basically three dots. 1, 2, 3, that we create a surface like that, then relative to that surface we get our view position, light position, to again calculate the direction in view direction. So using that light direction and view direction to calculate using the light direction, this time is going to be all relative to the normal surface. I guess that's what I understand. I probably am wrong. We get the following from this calculation. What is the following from that calculation? An error. Let's see. Invalid vector, parsing error. Can you say where? Line 46? This is invalid or? Oh, creation. No, what? Yeah, where's the error? What is the invalid vector? Did I like miss a semicolon somewhere? What is the invalid vector? What? In device create shader module normal shader. Parsing error. Did it change something? Let's go to our shader and quickly check everything. Vertex input, this instance, vertex input, bit tangent, tangent, vec3, vec3, vec2, vec3. Go to our model vertex 3 and 4 seems to be correct. What's the problem though? Really, no info. This is like the first time Rust gives absolutely zero info on what the error is. Parsing error, amazing. You usually say where the parsing error is. Let me just randomly remove this here. Yeah, it says this. Parsing error expected this. Fun return. Let's just copy this and paste it. Nothing seems to be changing. Let's copy this entire thing. Because with the amount of code there, it's like 100% certainty that I mistyped something. Let's see, it's in resources, meshes, paste. This is a model mesh. Does it work now? Yep. No idea what I fixed. Actually, no, we can check. Was the error in this? Nope, the error was somewhere in this shader. I guess I mistyped something. Model mesh. What could I have mistyped? I don't know, forgot a comma, but no, it usually says when I forgot a comma. It says incorrect vector creation. Could have been something here I misspelled, I guess. I don't really know. Well, okay, let's see what the product is. Also, wait, before we do this, window.set this gets nope. How can I set the window attributes? Is it like from let me create a new let window builder this. It creates a builder and do window builder dot window attributes. Can you create a window builder? It's not gonna work though. It's not like pointers. Seriously, just need to do clone. Nope, you're not. Oh my god. Why is changing size so difficult? Cannot assign to window attributes interstates, which is behind the window mutable. This is also going to be mutable. Yeah, there's going to be a borrowed mutable reference. This dot as, nope, I can't. Can I just do it mutable? No, I need to do a reference. Quick fix. Dot as mute. Will this help? Then I'm not gonna need this, right? I cannot assign to this expression. So let's return all the mutables. Nope. Let's remove this. Consider mutably borrowing here. That's gonna change something. I mean, it seemed to have changed something. Dot on nope. Okay, I'm not gonna bother with that for now. Let's run this and see how it looks finally. It looks not good. It looks like it's made out of metal. sRGB and normal textures. Textures sRGB is a non-linear color space. It is ideal for monitors because human color perception isn't linear either. And sRGB was designed to match the quirkiness of our human color perception. But sRGB is an inappropriate color space for data that must be operated on mathematically. Such data should be in linear, non-gamma corrected color space. When a GPU samples a texture with sRGB in the name, it converts the data from non-linear gamma corrected sRGB to a linear non-gamma corrected color space first so that you can do math in it. When GPU samples it. Okay, normal maps are already stored in a linear format. So we should be specifying the linear space for the texture so it doesn't do an inappropriate conversion when we read from it. This is like the most random thing to do in normal mapping. Paragraph. What? Okay, from image is normal map bool. Can I set this? Nope. Can you not do that? That's sad. Let's see, where do we create the texture? Right here. Before we do this, our format is going to be if is normal map. Oh, I guess I'm gonna have to delete this then. Oh wait, no, that's the depth format. We're gonna need it. Texture, format, RGBA 8 unorm, else, WebGPU texture format, RGBA 8 unorm sRGB. So dimensions format is going to be our format. Usage is going to be the same, and view formats are also going to be the same. And it still returns, so comma. We also need to change from bytes. Then now we go back to our resources, load texture. Oh, what? Why does this have? Oh, okay. It just didn't show it. Boolean. And in here we also do is normal map. And our diffuse texture is because the normal texture is going to be set to false, but here it's going to be set to true. Let's see. Still looks ugly. Unrelated stuff. I wanted to mess around with other materials, so I added a draw model instanced with material to the draw model trait. I found a cobblestone texture with a matching normal map and I created debug material for that. Wait, so you're saying that these textures are not matching? Cube? They seem pretty matching to me. I think this function is good. I'm gonna do this function, but I'm not gonna test out with different texture or anything like that. Even though it's simple, it's still nice. So we go to draw model. Function draw model instanced with material. Mutable of self. Our model is a reference with a lifetime. Material, also a reference with the same lifetime. Model material. Instances are going to be a range. Camera bind group. WGPU bind group. Light bind group. Amazing. I'm also going to do the same function, but draw model with material without instance. Let's go to, let's close this, no this, close this, close this, close this, and implement some new functions. Functions, draw model instanced with material for each mesh in model.meshes self.drawMesh instanced. Mesh material instances clone. Camera bind group, yep. then the function draw model with material is for each mesh. Actually, I'm just gonna do the self dot draw draw model with instance with materials. This instance is 0 to 1 and everything is the same. Yep. Then this is just not gonna use this, and in here as well. Let's see. Can I check how long I have been streaming for? Less than an hour, I think. Oh wait, no, an hour or something. Wait, if I can just open. Oh, an hour, 12 minutes only. And at that time, I had enough time to make a tantrum about this tutorial. That's insane. Okay. Let's quickly check if anything said something in Discord. Okay, and nothing interesting. I'm gonna get some water. You also don't forget to get some water. It's good for you. Okay. Back from water break. Oh yeah, I can delete this now. Let's see. A better camera. I've been putting this off for a while. Implementing a camera isn't specifically related to using WebGPU properly, but it's been bugging me, so let's do it. It's getting a little crowded, so let's create a camera RS file to put our camera code. You haven't done that? Even I did that. Come on, get on my level. The first thing we're going to put in are some imports of our OpenGL to WebGPU matrix. I mean, I'm already doing all of this. Oh wait, no, there is new stuff. Okay, let's just... maybe import that. I'm gonna do this. Oh, it gets everything from event. Okay, so that's fine. So let's do this back. Control Z. I then don't need this thing here. I can just use normal. And can't I just like select all of them? Like maybe Alt? I know that I can do Control Alt to have multiple of these guys, but that doesn't really help. Oh wait, no, this is actually going to be useful. What is instant duration? What's the library I'm going to have to include? Physical key. Oh, I accidentally import and no, don't fill them. Import, yeah. Okay, we also have to go to our cargo tomo. I don't think I'm using, yeah, I'm not using CFG if. I am also not using everything else I'm using. Okay. Let's go instant. Latest version is probably 0.1. Oh, 0.13. Oh, 0.13 even. That's not 0.13. The camera. So I guess we're gonna be remaking everything. FPS style camera. Oh, that's exactly what I need. I'm just gonna be copying all of this. You might say that I'm lazy, but in my defense, I don't know. I've done a camera like this before. That is my defense, yes. That I know how to do it. Projection, still the exact same thing. Actually, this might be, yeah, right hand, left hand. I will read this because sometimes I have problem understanding what that means. You can tell the difference between a right-handed coordinate system and a left-handed one by using your hands. Point your thumb up. Point my thumb to the right. This is the x-axis. Point your finger up. This is the y-axis. Extend your middle finger. This is the y-axis. On your right hand, your middle finger should be pointing towards you. On your left hand, it should be pointing away. Okay. Wow, it works. Who could have guessed? The camera controller. Same old spiel. I still don't get why it does like dot amount right equals amount. It's just like, why do that? Virtual key code. Ooh, so many errors. What do you mean? Just, it's an implementation error. Come on, even I know that. Winnet, keyboard. Okay, maybe no. What? What is virtual key? I've definitely seen it somewhere. Keyboard, key code, virtual key. What is it? I want to use it. Give me virtual key. Cannot find virtual key in the scope. Okay, let's go to the code. Source, camera res. It doesn't include it. It just uses it. Oh no, it doesn't. What is this? Why does it just all of a sudden... What if you updated it? How hard is it to update the other thing? Okay, I'm just gonna copy everything here, paste it here. Still the same, we create these guys. Okay. What is gonna be changing is this. So in our state, Wait, so camera uniform, it's here. Let's just go to the end, camera uniform. Update view position, camera dot position, and view projection camera. Oh, what is this? Projection. Dot calculate matrix multiplied by camera dot calculate matrix. That seems a little bit over confusing, but okay. And dot into. And let's add projection here. Camera matrix. Oh, projection, not matrix, yep. Wait, what is this camera? Okay. State. Okay, we're gonna be doing all of that later. So these are camera controller. So first, our camera is gonna be camera. Camera controller is gonna be camera controller. And our projection is gonna be our camera projection. I'm actually gonna do this. So I do camera this here, so it's more consistent. Should also make an error down here. Okay, this is gonna be fixed later. Mouse pressed boolean. Mouse pressed type boolean. Implement for state. Let's see, what are we making? Camera is gonna be camera. Remove all of this. New position 0 0 5 0 10 0. Our CG math is gonna be degrees minus 90. Hey, please, for God's sake. Oh my god. And our pitch is minus 20. So projection, camera controller. Oh, it's not mutable. Wait, what do you mean camera is not mutable? Okay. Yeah, that's... Oh, down here it's no longer mutable, but don't we change... Oh no, we don't need to change, we just take this. So here we no longer need this camera controller. Let's scroll down here. Mouse pressed false. And camera controller and projection. Okay. We also need to change our projection and resize. Where is resize? Self dot projection dot resize new size dot width new size dot height. Don't forget this. input function event okay, so let's go to my main. Let's go to input. So this is gonna grab our event, window event, if okay, that doesn't matter. Let's just remove this for now. It's gonna be event, and in here we're gonna take all of this, paste it here, event, window event. I'm gonna delete this because I do not need a return statement or anything like that. Physical key. Okay, let's make it return a boolean. Let's just copy this against the entirety of the function. So now that we go to main, can I just avoid this because I do not need this? Method input is private. Oh yeah, public function. I avoid that, and here, and event loop. Match event, event type of window event, just copy this, I guess. Let's see what's changed though. So we're not using device ID currently. If state.mouse pressed, process mouse delta 0 delta 1. Event window event. If it's equal and it's not an input from our state, then we're gonna match the events. Okay. Sometimes it's useless to. Why is there / 3 dots there? Oh, because I still need to redraw requested. Right. Yep. So let me take this closer requested, put it here for now, then copy all of this. Paste it here, and copy this back. Paste it after a scale factor change. What? I didn't notice this. New inner size, resize. Okay. It's private. Let's make it public. Also, what's the error here? What does it take? Projection is missing. So dot projection. Okay, let's go back up here. Let's make this public. Camera controller is private. Let's make it public. Let's make everything here public. Camera and this device, we can import that. Window, I don't have the function, I have the variable. Match event. Instead of filling the arms, what I'm gonna do is I'm gonna put a comma here and just null everything. Variant scale factor change does not have a field named. Which fields does it have? Okay, I'm just. Wow, how did that? Oh my god. Dot unwrap. Physical size, we don't need this. Let's see. I'm still not a big fan of the fact that. Where is the function being called? Oh, nowhere. Okay. That's fine. Update. Update camera. Oh, okay, fine. That also works. Update. We are gonna have to update the camera controller. I removed this like 2 streams ago because I rewrote it a little bit differently. DT instant duration. And the error here. Event redraw requested. And then we don't need this then. These 2 functions are not needed for now. Last render time is not in the scope because we need to create it there. Amazing. Now let me check out the code and just. Is it here, very bottom? Let me just copy the entire event loop. Yeah. I really don't like how I need to click, but I guess that's fine. Oh, this is a big one. Okay, yeah, definitely not today. I want to go do something else now, and I'm gonna stop stream. But tomorrow is gonna be the final day. We're gonna be finishing this whole thing with high dynamic range rendering. After we're finished with that, we're gonna actually start working on the engine. It's gonna be a simple engine for old style 3D games. They're called like boomer shooters, yes, that's the name. Amazing name. And yeah, this has a lot of chapters from. Wait, there's even more here. delete this. Because they're switching to HDR, which is high definition rendering, which allows us to do some really cool stuff, visually of course. Loading HDR textures, cube maps, that's a cool thing as well. Oh, whoa, what is this? You may have noticed that we have switched from down-level WebGL to defaults to down-level defaults. This means that we're dropping support for WebGL. Yeah. Suck it, WebGL. So compute shaders, skyboxes, which is cool. Reflections, which is also cool. And yeah. Let's see what we should end up with. This seems like an example. Nope. Okay. Well, we're not gonna be trying it out then right now. Well, anyways, thanks everyone for coming. Tomorrow's gonna be the last stream. Then we're gonna be doing really cool stuff. Have a good day and goodbye. And I've also just realized that my microphone was not in the correct place, so I might